So I hope that you have answered the 10 questions within the 10 minutes. Okay, so this is a mock test series of EC Electronics in which we'll be preparing for the examinations that are going to come very soon, which are Keltron Engineer and Trainee Engineer exam, and also BARC Stipendiary Trainee examination, and the ISRO Technical Assistant examination. Okay, so for all these exam preparations, we are going to actually do mock test subject wise, so that it will be actually beneficial for all the examinations. So that's why I plan to make the mock test subject wise for all the exam preparations. Okay, so I hope that you have answered the 10 questions within the given 10 minutes. So every question answering time is allotted as 1 minute. So try to answer these 10 questions within the 10 minutes. And also, if any of your friend is going to attempt the examination of Keltron or BARC examination or ISRO Technical Assistant examination or any examination of electronics for that matter, please do share these videos with them. Okay, so let us see the answers without any delay. So the first question you can see on board, these questions are from digital electronics subject. Okay, so this video will be uploaded in the digital electronics playlist. Okay, so the first question is, in a sequential circuit, the output at any time depends only on dash. A, past output values. B, intermediate values. C, both past and present input. D, present input values. So we know that you can actually classify the systems, digital systems, mainly as two categories: sequential and combinational ones. Okay, we have already discussed about these concepts. Anyway, we'll discuss it further. Once more. So combinational circuits are there and sequential circuits are there. Now, combinational circuit means you're going to give an input to this circuit, you will get the output. Okay, so there is only input and output. There is no dependency of the output to the next state or next output which is going to come. But for the case of a sequential circuit, there is actually a feedback path, and in the feedback path you are going to connect a memory element. And so here there are present inputs and also the outputs are being connected with the feedback to the input. So at any particular time, that output at that time will depend on not only just the present input but also on the past outputs because of this feedback. Okay, so here these are sequential circuits and these are combinational circuits. Now the examples of combinational circuits are adders are one examples. Flip-flops are examples of sequential circuits. Okay, now if you ask the answer of this question, the question is actually asking the output at any time depend only on dash. It is actually depending on both past output and present input, right? So the correct answer is C. Okay, I hope it is clear. Please note down these two diagrams which will be very useful. Here you can see there is no feedback or no memory, but here there is a memory. Actually, if you add a memory to a combinational circuit, it will be converted to a sequential form. Okay, so this is the answer for the first question, which is option C. Moving on to the next question. Next question again you can see on board. Next question is from K-map. Each one entry in a K-map square represent dash. I'll read out the options for you. A high for each input truth table condition that produces a high output. Okay, then a high output on the truth table for all low input combinations. C, a low output for all possible high input conditions. D, a don't care condition for all possible input truth table combinations. So here each one entry in a K-map square actually represents a high for each input truth table condition that produces a high output. That is the correct answer. And this one is actually called as min term. So in a K-map you call this one as min terms. That is, when you are going to write in a column you are going to write a 1, it is called min term. Then zeros we call them as max terms, right? So ones are actually, it is actually representing a high value for each input of the truth table condition that is producing a high output. Okay, So that is the correct answer. It is actually representing a high value. It is not low, it is not don't care. It is a high value. Okay. So the correct answer is option A. Okay. Next question. Again, we have done a separate video on K-maps. K-map, what is the SOP representation, what is the POS representation, what are min terms, max terms, everything I have done as a separate video, and that has been included in the digital electronics playlist. Okay. Now moving on to the third question. The decimal equivalent of a binary number, the binary number is given here. 1, 0, it is actually having numbers after the decimal point also. Okay, so it is a little bit difficult one. 1011.011 to the base of 2. Okay, 1011.011 to the base of 2. And what is the decimal representation? That is to the base of 10. If you write this number, what is the value? That is a question. Okay, now how to do this problem? You have to take powers of 2, right? So I'm going to put a 0 here. Then there is a 1, there is a 2, there's a 3. Here, minus 1, minus 2 and minus 3. Now these are actually position values. Okay, this 0, 1, 2, 3 and minus 1, minus 2, minus 3 are position values. You have to take this as powers of 2. That is 2 raised to 3, 2 raised to 2, 2 raised to 1 and 2 raised to 0. Then 2 raised to minus 1, 2 raised to minus 2 and 2 raised to minus 3. Now, wherever you are seeing zeros, just cancel it. Here also you can see a 0, just cancel it. The remaining terms, just multiply and take the product. Sorry, take the sum. So, here 1 into 2 raised to 3. I'll start from this side, okay. 1 into 2 raised to 3 plus 1 into 2 raised to 1 plus 1 into 2 raised to 0. Then again a plus 1 into 2 raised to minus 2 plus 1 into 2 raised to minus 3. Okay, that is just take the, you just take the sum of these powers, because anyway you are going to multiply it with 1 only. So the answer will be the same. But the concept or this method is like this. You have to take the product of the number on top of it with the 2 to the power. And wherever you are seeing zeros, here there was a 0, right? So the below 2 to the power term you can cancel, because you are going to multiply it with a 0. So anyway it will get cancelled. So you will cancel it and this is the term you are getting. Now if you take the value here, you will be getting, you have to actually take the products and then take the sum. That is 2 raised to 3 plus 2 raised to 1 plus 2 raised to 0 plus 2 raised to minus 2 plus 2 raised to minus 3. Now this is 8 plus 2 plus 1 plus 2 raised to minus 3 plus 2 raised to minus 2 plus 2 raised to minus 3, right? So it will be 11 point something. 8 plus 2 is 10 plus 1, 11. 11.357. That will be the answer coming. Just find the value, you will be getting the exact value. Okay, 11.357 to the base 10 is the correct answer. And the correct answer for this question is option A. Okay, so this is how you take the value. That is, if you are going to convert the value from binary to decimal, this is how you do it if you have numbers after the decimal point. So there is a decimal point here. After that decimal points also there is number. So you have to take the calculation, or you have to do the calculation like this. Okay. So here the correct answer is option A. 11.357 to the base 10 is the correct answer. Okay. Now moving on to the next question. That is the fourth question. Fourth question is, okay, the largest 2-digit hexadecimal number is dash. Okay, the options given are FE to the base 16, FD to the base 16, FF to the base 16, EF to the base 16. Okay, you know that in hex representation, the highest number in hex representation is F, right? F is the highest number in hex representation. So anyway, if you blindly guess this question, the question answer will be coming as FF to the base 16, right? Because the other numbers given are either FE or FD or EF. So anyway, F is the highest value. So FF will be the highest value. Anyway, if you are going to convert the other numbers also, you will get the values like this. I'll write the values here. Okay. Fe to the base of 16. If you find the value in decimal, you'll be getting it as 254 will be the value coming. Next, Fd to the base 16, if you convert in decimal, you'll get is 253. Okay. Next, Ff to the base 16 is actually 255. Then next one, that is EF. EF to the base 16, that is the last one, right? So EF to the base 16 is 239 only. Okay. So the numbers are 254, 253, then 255 and 239. So which one is the biggest one? It is 255 only, right? So the correct answer is, anyway, if you blindly guess also, you'll get it as FF to the base 16. Okay. Correct answer is option C. And if you want to convert the values in decimal and if you want to compare the values, then again, here you can see it very clearly. FE is just 254. FD is 253. FF is 255 and EF is 239. So correct answer coming is option C only. Okay. Correct answer is option C. Next question. Fifth question. Okay. Fifth question is in a 1:4 demultiplexer, if C1 equal to 0 and C2 is equal to 1, then the output will be dash. Okay. So I'm going to draw a demultiplexer here. This is a 1:4. 1 input, 4 outputs. This is Y0. I'll write name according to the options Y1, Y2 and Y3. Select lines you are going to give us C1 and C0. Okay, this is a 1:4 demux. Now, the question is asking if select lines is the combination C1 is 0 and C2. It is actually C1 and C2. Okay, so it is C1 and C2. Okay, C1 and C2, if it is 0 and 1, then what will be the output? Let X be the input. Okay, so for 0, 1, it is actually going to select Y1. Okay, so these are the combinations. I'll write it here, C1, C2. If it is 0, 0, output will be Y0. If it is 0, 1, output will be Y1. If it is 1, 0, output will be Y2. If it is Y1, 1, output will be Y3. Okay, so this is the truth table coming for a demultiplexer like this. Okay, here it is actually going to have a combination 0, 1. 0, 1 means this is the combination and the output will be Y1 will be the output, which is option B is the correct answer. Okay, you just have to know the concept of a demultiplexer to answer this question. There is nothing difficult. Okay, correct answer is option B. Next question. Next question is, in a SR flip-flop, if Q is 0, the output is set to be dash. A set, B reset, C previous state, D current state. Okay, so this is question number 6. Then S and R combinations. If it is 0, 0, then it is previous state, right? That is Q previous. Then if it is 0, 1, it is said to be reset. Then if it is 1, 0, it is said to be set. And 1, 1 state is actually not defined condition for a SR case. Okay, here question is asking, so this is the Q, which is the output, right? And the values will be coming as here Q is equal to 0 here, then Q is 1 here, right? So if the output Q is equal to 0, these are the two cases. Here whatever previous value is coming, it will be same as the present case. Now the question is asking in the reverse, that is if the value of Q is 0, then what is the state set? It is called reset state. Okay, if Q is 0, it is reset state. If Q is 1, it is called set state. Okay, so I'll read out the question once again. In a SR flip-flop, if Q is 0, the output is set to be dash. The output is actually reset condition, or it is a reset. So correct answer is option B is the correct answer. Okay, next question. Seventh question. Seventh question is, the output of latches will remain in set or reset until dash. So the latches will actually retain the value until dash. A. The trigger pulse is given to change the state. B. Any pulse given to go into the previous state. C. They don't get any pulse more. D. The pulse is edge triggered. Okay. So the output of latches will actually remain set or reset until the trigger pulse is given to change the state. Okay. So they are not having actually clock signal. So in order to actually change the state, we have to apply a trigger signal. So until the trigger pulse is given, it will retain, or the value will remain as same. Okay. So you have to apply a trigger pulse. Correct answer is the trigger pulse is to be given. Okay. You have to apply the trigger. Okay. So trigger pulse has to be applied to change the state from either set or reset. Okay. Anyway, the condition is only changed when a trigger pulse is applied. Next question. Eighth question. Eighth question is, the example of dynamic memory is dash. A. CCD. CCD means charge coupled devices. Okay. Then semiconductor dynamic RAM. C. Both CCD and semiconductor dynamic RAM. D. Floppy disk. Correct answer is the example of dynamic memories are CCD and semiconductor dynamic RAM both, because the contents of both the memories changes with time. So they are called dynamic. Dynamic means it is actually changing with time. Static means it is not changing. Okay. And CCD full form is charged coupled devices. Here the correct answer is option C, both. Okay. Next question. Ninth question. Ninth question is regarding PLD, that is programmable logic devices. PLD contain a large number of dash. A. Flip-flop, gates, registers, C. Registers, D. All the mentioned. Actually, PLD contain all these things. PLD is a collection of large number of gates, flip-flop, registers are interconnected on a chip, and we can actually use this PLD, that is programmable logic devices, to realize any circuit or any circuit diagram. In order to realize, we can make use of this PLDs, and this PLDs is a combination or a collection of registers, gates and flip-flops and all these basic elements. Okay, so that is a PLD, that is programmable logic device. So the correct answer is D, all the mentioned. Okay, next question, that will be the last question of this video. 10th question is actually to perform a binary multiplication, and the numbers you have to multiply are, I'll write the numbers here, 0, 1, 0, 0, 1. That is the first number. And the next number is 0, 1, 0, 1, 1. Okay. So these are the two numbers. You have to take the product of these two numbers. Okay. 0, 1, 0, 0, 1 and 0, 1, 0, 1, 1. Now, the rules of performing binary multiplication is, if you take a product of 0 into 0, the value is 0. 1 into 0 is 0. 0 into 1 is 0. Then 1 into 1 is 1. Okay. So this is the rules of performing multiplication. Now, how to perform this binary multiplication, let us see. First, you have to take the product, that is, take this number, multiply with all these numbers and write it here. Okay. So 1, you're going to take a 1. So 1, then 1 into 0 is 0, then 0, again 1 and 0. Now, take the next number, which is this one. Again, take the product and start writing from here. Okay. So it will be 1, 0, 0, 1 and 0. Okay. Next, take this number, that is 0, and you are going to multiply and start writing from here. 0, 0, 0 and 0. Yeah. Next, again a 1. So you have to take this 1 and take the product. You'll be getting 1, 0, 0, 1 and 0. Okay. Yeah. Next, take the last one, which is the 0. So you have to write from here 0, 0, 0 and 0. Okay. So this is how you are going to get the numbers if you take a product. That is, if you perform the multiplication, you are going to get the numbers like this. Now, just add these numbers in every column, just like we do for normal multiplication. So it is 1, 1, 1. Yeah, only 2 ones. Okay, 1, 1, then 0. 1 plus 1 is 0, carry 1. Again, 1 plus 1 is 0, carry 1. So it is a 1 here, a 1 here and a 0 here. So this is the number which is going to come, and the answer is 0, 1, 1, 0, 0, 0, 1, 1. Okay. Now if you, these numbers, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is the number which is going to come. Okay. So it will be, if you want to add a 0 here, then it is no problem, because we are going to add it in the LSB. If you see the options are actually given as numbers which are having 9 digits are there. Okay. So every option is having 9 digits. So in order to make it in that form, if you have to add a 0 here, then no problem. You can add a 0 here. Okay. So this will be the answer coming. And the correct answer is option A is the correct answer. Okay. So the correct answer for this 10th question is option A. And the answer that is coming is 0, 0, 1, 1, 0, 0, 0, 1, 1. That will be the answer coming. Okay. So we have discussed 10 questions from digital electronics. So we have discussed 10 questions from digital electronics in this video. So in the upcoming days, we'll be doing various subject-wise mock tests for this exam preparation. So if you are preparing for Keltron examination or BARC exam or ISRO examinations, please do see these videos and also share it with your friends who's preparing for this same exams. Okay. So if you found the video useful, please do give it a thumbs up. Also share it with your friends. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.